Alright, in this video we're going to continue talking about polygons and a specific property of polygons. We're talking about diagonals. So a diagonal is a line segment that connects two non-consecutive, so that means that they're not next to each other, not in a row, two consecutive vertices. So if you notice in our picture here, I have this diagonal which connects a vertex over here, and then I skip this vertex here because it's right next to that one, and then I can connect it over here. So if I'm starting at this point here, I can draw a diagonal to any of the other points except for this one and except for this one, because those are next to the original one that I started from, right? And then we have another diagonal here which connects two non-consecutive vertices. If I wanted to draw all the rest, I could draw a diagonal here, and I could draw a diagonal here, I could draw a diagonal here. And notice in this particular case, from any point we were able to draw two different diagonals. So two from that point and then two from that point. So we're going to be talking about how do you figure out, well, what's the most amount of diagonals you could draw in a particular polygon. Alright, so what I want you to do, just to check and see if you have an understanding of what we're talking about so far, is go ahead and pause the video, and in these two examples draw in as many diagonals as you can, and then we'll name those. So again, pause the video, draw those in, and then restart, and we'll compare our answers. Alright, so here's what I got for example 2 parts A and B. In the first one I've got two diagonals. Just makes an X on our square here, and then over here on our hexagon I've got 9 diagonals. So you can see that from each vertex I've got 3 diagonals. Okay, so keep this in mind. We're going to start looking for some patterns to figure out how many diagonals we could draw in a polygon. And if you didn't get those, make sure you get some help. The next topic in our video are two special types of polygons. So we have convex polygons and we have concave polygons. So notice the difference here. For a convex polygon, I've got diagonals drawn in these 3. For my triangle, we don't have any diagonals, but for these other 3 figures, all of my diagonals are completely inside the figure. All diagonals are inside. However, over here, notice I have this diagonal over here which is outside the figure, and then I have a couple diagonals over here and over here. Those are outside. Here's some diagonals that are outside. Okay, so if it's concave, one or more diagonals or part of those diagonals are outside. So sometimes I like to think of these as polygons that have been caved in on the sides. Okay, so you can see like this has been pushed in over here, and that side has been caved in. So now it's smushed. Okay, so we have convex. All the diagonals are inside. There's no sides that have been caved in. Over here, and then over here, some of the sides have been caved in. Here, these 2 sides have been pushed in. So you can see the difference. Just some more vocabulary for you. Make sure you know that. Alright, then what I want you to do is I want you to classify each of these polygons as concave or convex, and I'll take a look at that when we check your notes. And that's it for this video. Make sure you get any of your questions answered, and we'll see you in the next one.